Hello, today we are brewing a fancy lawnmower Kolsch, nice summer beer for the winter time. We are using our 3-vessel, 20-gallon HERMS system. So right now we have the pumps running. I have my strike water of 29 liters in my mash tun, running through the HERMS, through the pump into the HERMS coil in our HLT, and we have our HLT pump running as well, just to recirculate and we're getting ready to mash in. So we're mashing in pale malt, Munich light, and a little bit of wheat malt. That's not all. So yeah, we're just doughing in or mashing in here with our milled grain and just making sure we're stirring everything up, and we don't want any of the grain to stick together. We want it all nice and hydrated with our water. We're mashing in at 68 degrees Celsius, which is about 153 Fahrenheit, and we're targeting a mash temperature of 65 degrees Celsius, which is, I believe, 149 Fahrenheit. Three vessels. I'm just going to talk about what I really like about this mash tun setup. We have a bit of an oversized pump that we're using for the mash tun to recirculate through the HERMS coil and the hot liquor tank, and it's just giving us the ability to have a little bit of a higher flow rate to help us maintain the temperature and maybe narrow the gap between the temperature that we need the HLT water to the temperature that we're going to maintain in the mash tun. The mash tun is doing, like with the oversized pump, we would think that we might have an issue with compressing the grain bed. However, the laser cut mash filter is actually like very effective, and it has so many perforations that I'm not concerned with sucking the grain bed right down and compressing it. So we've got a little bit of flow here. I'm just going to pull up the hose. So yeah, we have a pretty solid flow, and that's just helping to maintain the temperature at 65 Celsius so we get alpha amylase conversion. We're working with this Brew supply control panel today to run our 3-vessel brewing system. So right now we have our boil here on the left. Obviously we're not in boil yet. We are in the mash. We're currently recirculating through the HERMS system in the HLT. You can see the HLT here is all red in the background. That's showing that it is turned on. Same with our pumps. They're blue when they're on, so when they're off, they're black. Here we can look at the mash schedule, which allows us to have 4 different mash steps. If you wish to do like a German Pilsner or a Saison, where you have maybe perhaps some unmalted grains and you want to do like a beta-glucanase or a beta-amylase rest, then that gives you the opportunity to schedule it in. And it's really nice, the steps won't start until you've hit temperature. Here in the fermentation control, if we had it plugged into the fermenter, the temperature would be at the top, and then the middle is what we've set the temperature to be in the fermenter, and then it'll activate or deactivate the solenoid to activate cooling in the jacket. And then here we have our auto start control system, which I really like. I think it's the best part of the system. It automatically can turn on the HLT to start heating up and recirculating the water. Takes us about an hour ahead of time to heat up 75 liters of water. We can go back to the menu, and then in settings here we can play around with the fermentation settings between, we have 2 fermenter controls, and then we also can adjust temperatures in the HLT boil mash ton. And then we can also switch from Fahrenheit to Celsius, which is a really cool option depending on where you live and what you're used to. And yeah, it's a great system so far. Okay, we are just approaching the end of our second mash step for our mash out. So I'm just going to turn off our wort pump so we can move some hoses. We can make sure all our valves are closed. And then we are going to move a hose. We can just open this a little bit just to get a little bit of flow. Just start the process before we start sparging. And then we're going to detach our recirculation connection here so we can connect our sparge arm.
Want to show us the sparge arm before you put it in?
So this is a sparge arm. It's got perforated holes on the bottom for sparging, but not on the top. And then we're using our quick connect. It goes out just over halfway into the mash tun. And the ball valve allows the opportunity to make finer adjustments of the flow rate. And then we are going to turn off the water pump. Close the valves. And because our HERMS system has water in it, we want to get that, or has wort in it, we want to get that water out. So we're going to run our sparge water through the HERMS system. Oh, that's the wrong one.
Good. And making mistakes is okay, right? Just
making
mistakes. When you say it, it's fine, right?
Yeah,
it's like
that's the easy part about having the quick connects. It's like, oh, I misplaced a hose. It's easy to fix. Get the water pump going here. Then we can dial in our flow rate.
Okay, so there's the sparge.
So we're just starting the sparge, and I can adjust the flow rate here with the ball valve. I just want to keep the grain covered. It's good to check the volume of your HLT when you start sparging so you know what your starting volume is. All right, so we're sparging here with our 3-vessel system. As you can see, I can control the flow rate with our ball valve, and that's matching the flow rate of our transfer to the boil kettle as we slowly fill. This allows us the opportunity to sparge at a temperature from our HLT. And the sparge arm is only meant for sparge water. It's not meant for wort or Vorlauf water. So when we were recirculating the mash earlier, we were recirculating through the hose. It allows, if there is chunks of grain that come through, they can go through easily and they're not held up. If you try using the Sparge arm for Vorlaufing, it's going to get plugged. The holes are too small to allow husks or endosperms or chunks of starch or anything from the mash. It'll just plug it up, and then it's a bit of a pain in the butt. You gotta take it off, unplug it. So if you use this to recirculate the mash and then only use the Sparge arm for sparging, would be the most effective use of the equipment.
And tell us a story about the Unibrow system.
The Unibrow system is good for using the Sparge arm when you're sparging, and when you're Vorlaufing, it's better to not use the Sparge arm. It will get plugged. When we recirculate it in a professional brewery setting, the Sparge is actually like little sprayers, and it's easily plugged with grain, and it does happen. But not knowing that you should run your mash through your Sparge is a mistake that a lot of beginners will make.
Dude, so basically, you're a fucking idiot.
I won't say that.
If you're using the Sparge arm to Vorlauf, is that what you're trying to say?
Yeah, don't be an idiot and Vorlauf with the Sparge arm.
Okay,
it's not funny. All right, so we have hit our kettle full volume here, and we're just gonna check the gravity and see where we're at. So I just want to we're using refractometer to check our pre-fermentation gravity, just make sure there's lots of wort on there. And we are at 1.041. So that's hitting our pre-boil volume target. Was 1042, so it's very close, at 68.5 liters. We set the mash efficiency for 85%. We used the system last week and we hit over 90%. I think something that I don't even hit when I work in a professional brewery is we usually aim for around 83%. I think what's really making the system more efficient and more effective is that the mash plate in the bottom for filtering has 1,200 perforations that are laser cut. It's designed to increase the efficiency, and we're showing that here with this system today. And then I find that the best part about that is we're using this control panel and the HERMS system, which is allowing us to recirculate our wort through the HERMS coil, and in our HLT helps to maintain the temperature as close as possible. We found a 3-degree variant, whereas the HLT needs to be 3 degrees hotter. So we have this set at 68 degrees and our mash is at 65 degrees, consistent over the full course of an hour. So it's very, very efficient that way. And that's helping us increase the efficiency of our whole brewing process. So we're just getting to a nice stable boil here of our Kölsch, and I've got some Hallertau Tradition hops that I'm gonna add. Typically I would usually use Mount Hood hops, which is like a North American noble variety, but because it was unavailable, Hallertau Tradition is a very similar noble hop and is true to style for this Kolsch style of beer. So we're adding 3 ounces for bittering at 60 minutes. And that should give us about 18 IBUs.
Good.
All right, so we're coming to the end of the boil. We have a 5-minute hop addition here, and we're going to use a mixture of Hallertau Tradition that we also used in the 60-minute boil bittering addition, and an ounce of Cascade to bring out a little bit more citrus, pine, grapefruit that we're really looking for in this Canadian Kolsch. There we go. Give that 5 minutes and all right, so we finished our boil and we have a Whirlpool loop set up. I'm just gonna take a gravity reading and then I'll show you our loop. Just a little dab there. That's awesome. It's reading 1048, which is exactly what we wanted. And so yeah, we've got this loop set up for our Whirlpool, and at the same time we're sterilizing our heat exchanger. So we're coming out of the bottom of the kettle, coming into our wort pump, coming out of the wort pump and going in line, and not counterflowing to sterilize, but in line, and then we have a probe here that we're going to use to measure our temperature when we are doing the transfer. So that's in the sterilization loop. And then we're coming out of that temp control, and then we're feeding back into the Whirlpool side port here. And I just have it kind of tampered down a little bit because the pump pushes pretty hard, and we don't want too much of a turbulent Whirlpool. Just nice and calm. It's only 5 ounces of hops in there, so we don't need to do too much.
You can see it spinning.
Yep, 20-minute sterilization time is perfect with a 20-minute Whirlpool time. We're at the end of the Whirlpool, and we have sterilized our heat exchanger. So now we are going to, when we're ready, we'll open the bottom of the kettle, lead us into the pump, and then coming out of the pump will bring us into the heat exchanger. It'll go through the heat exchanger, counterflow against the water, and then coming out of the heat exchanger we have a temperature probe, and that'll measure our temperature coming out. We'll spin around and get into the fermenter. So we're opening the bottom of the kettle, turning on the water, and then turning on the wort pump. And I'm gonna I have to limit it over here.
What are you doing there?
I'm limiting the flow. I can only limit the flow so much going into the fermenter, so I'm limiting the flow coming out of the pump as to not cavitate the pump. And then we're just going to maintain watching the temperature drop down to pitching at 18 Celsius. So we were up over 60 there when we first started. Now we're dropping 42, 41. It'll take a minute or two to drop to cast out temperature. We are casting out from our kettle through the heat exchanger to the fermenter, and we've limited the flow both at the entry point of the fermenter and also at the exit point of the pump, just to try to limit or slow down the flow so we can get the proper cooling temperature. We've gotten it down to 24 degrees Celsius. Like to come down to about 18 ideally. So we're just going to go in here on the panel, and our fermentation's activated. I've set the fermenter to 15 for now, just to help to bring the temperature down as we're cycling water through it. And the wort isn't yet at the probe, as the probe is sitting mid fermenter, but it is working. All right, we've come to the end of the brew day today, and we've got all the wort in the fermenter. This little beauty is 30 gallons, and we brewed 15 today. We put in 58 liters into it today. It's a jacketed conical fermenter, so we run cold water from the tap, and it's kind of hidden. We have a solenoid just in the back here, and that is actuated by the control panel that we had kind of reviewed a few times earlier. So on our fermentation graph here, we have the fermenter. I have it set at 18 degrees. It's currently at 17, so get it down there a little bit, so it's give it an opportunity to free rise as fermentation begins. I've pitched in a few packs of Lallemand Kölsch yeast, which is similar to K97 if you use the fermentous dry yeast. And yeah, it's a beautiful little thing. I really like that it's got a big 4-inch tri-clamp fitting on the top, so it's easy for me to pitch yeast out of the Erlenmeyer flask, and it's still got space for the airlock. Yeah, I'm really excited to see how this turns out. I'm gonna try to ferment this out at 18 degrees Celsius, which is roughly 67 Fahrenheit. So it's gonna be a really nice lagered ale. Kind of my final thoughts on the day. This is our second time using the panel, and the first time it was a lot of like trial and error and trying to understand the system and the way it was set up and how to manipulate the process to produce what we wanted to produce. So we started with a hazy IPA last week when we did that, and it was a good introduction. Today there were still a few little like challenges trying to figure it out, but I gotta say the efficiency of the panel with the 3-vessel brewing system all cleaned up now, but I was really impressed with the mash efficiency. And I had mentioned before about the mash plate, about the mash filter, and all the laser perforations that are in it. And I think this is really what's giving us some great efficiency. So the hole in the middle is obviously for our drain, and yeah, it just does an amazing job. Considering that we're recirculating the mash for the full 60 minutes, we don't have any problems with the grain bed compressing or just like sucking down and having no flow. We have great flow the whole hour and all the way through sparging and casting into the kettle. So yeah, the system's working really efficiently. It's just small tweaks. We used a bit bigger of a pump today for our wort pump. We kept the water pump on the small size. So that was an interesting challenge, like trying to adjust with the temperature of the cast out to the fermenter. But I think it's a good learning curve because we could use the jacket of the fermenter to help bring down that temperature. We were kind of casting out temperature in the fermenter as we were going in was about 24 Celsius. So just using that jacket just to bring that temperature down a little bit more was really efficient. So yeah, was overall happy. Hopefully this will be fermented out in about 7 to 10 days.